You guys have seen me build several gravel bikes on this channel and they always end up costing more money than I think they will. In 2026, it's tough to put anything together for under $1,200, especially if you're buying the frame and then all the components. The way to hit our budget here, or at least keep it as low as possible, I'm not going to buy anything new and I'm not going to buy anything pretty. Instead, I'm going to buy parts that don't work, I'm going to buy ugly parts, and then I'm going to fix them myself. Let's start with the frame. This is the first thing I bought for the project. This is a Niner RLT9. This is an aluminum gravel bike frame. I got it for under $100 and I got it that cheap because there's a big dent in the down tube. Repair-wise, this dent is in about the best possible place it could be. On this frame, the cables and hoses run down through the inside of the down tube and they exit right here. So this section of frame, or this section of down tube, just ends. It's not reinforced, it's just the end of the tubing. Because this is welded, it's so well made around the bottom bracket, I could actually cut this out. The frame wouldn't know any different. So having the ding here, from a structural perspective, is ideal because fixing it, we're not going to weaken the frame. The way I'm going to fix this is I'm going to make a clamp that slides in there. Then when I tighten it down, it'll squeeze the metal here, should push the dent out and flatten things out. The width of this part of the frame, this flat section, is, about 19.5 millimeters. So I'm gonna make a clamp that is 19 millimeters wide that will slip in behind this. I got lucky. I actually found a piece of metal that was already the right size. Look at that. So the way this is gonna work is I've got this piece. I'm gonna drill 2 holes in it and tap those. That will fit inside the down tube like that. And then I've got this other piece, I'll drill it as well. And then when I tighten those bolts down, these will be squished together and it'll push out that dent. Here's a better look at that dent. It's a pretty respectable dent. The idea here is simple. Insert the tool, tighten down the bolts, it'll clamp down, flattening out the dent. I realized the jaws on this tool were too thick to fully fit into the frame. I used my mill and cut a taper so it would fit fully behind the dent. That worked. I slid the tool in place, it fit fully behind the dent. I then clamped it down by fully tightening the bolts. I was able to push out most of that dent. There is still a little ding, it's not deep, but I want the thing to be smooth. So I'm going to mix up some filler and I'm going to fill that in. Then I'll sand it smooth so that when it's painted you won't know it was there. I applied a thin coat of 2-part filler and sanded it smooth. I then applied a heavy coat of high build primer. This will fill in any small defects. I feathered the primer and applied 2 coats of white paint. I then wet sanded the repainted area to blend it into the original paint. I was really lucky with this ding. It was in a repairable spot. I was able to get to the entire backside and push it out. If your dent is in a tube and you can't get to the backside, that is way harder to fix. If your dent actually has a crease in it, so you can see a sharp crease, there's really no way you're going to pull that out. I used a sanding pen to clean out paint chips, then applied a coat of touch-up paint. I went around both the frame and the fork and filled in all the paint chips I could find. I let the paint dry overnight to make sure it was fully cured. To restore the paint's luster, I used a rotary buffer and some rubbing compound. I fully polished the frame and the fork. This removes small scratches and scuffs and will make the paint shine like new. There were sections of paint that had rubbed off from use, the area where tires and cables had rubbed. Instead of using touch-up paint in those areas, I use colored vinyl. This will hold up much better to future rubbing than paint will. The headset bearings were rusty on the outside but in good shape otherwise. I ran them on my bench brush to remove the rust. I then greased them to prevent future rust and I installed the fork. I found a stem and a pair of flared handlebars in my parts bin that I thought would work well and I installed them. I'm really excited to see how it looks with this white stem. I'm using a pair of Shimano RS685 levers. These levers are hydraulic cable actuated 11 speed. They've got carbon fiber levers. They're pretty cool. I got these for $108. That was with tax and shipping, and that included the calipers. I got them that cheap because neither shifter shifted. When you would shift, they would shift up just fine, but when you let go, they would just shift right back down. It wouldn't catch. So basically the ratcheting mechanism in both shifters didn't work. To fix that, I took the shifter as an assembly and I put it in the ultrasonic cleaner. I ran it for about 20 minutes. That cleaned out everything from inside the mechanisms. I dried them out with some compressed air and then I applied some touch-up paint to cover the scratches. I chose not to fully repaint the bodies. These levers are going to be used for gravel. They're going to get scratched up, so spending the time, energy, and money to repaint those really wasn't worth it. I let that paint dry overnight, and then I liberally sprayed both mechanisms with some silicone lubricant. This is perfect for lubricating shifters. It's got a solvent in it. When you spray it into the mechanism, it will clean out anything that we missed in the ultrasonic. That then evaporates away and it leaves a nice lubricating film of silicone. After lubricating the shifters, both mechanisms now work perfectly. These shifters work exactly like they should. I refitted the hoods and now the shifters are ready to go back on the bike. I'm using Shimano's GRX wheels on this build. These are the RX 570s. They're the higher end version of Shimano's aluminum gravel bike wheels. These sell right now for $480 brand new. I didn't pay anywhere near that. I got them for $40 and I got them that cheap because neither one is rideable. The rear wheel, it's missing 2 spokes and it's got a large gouge in the rim that looks suspiciously like it was done with a grinder and a cutoff wheel. And the front wheel, it's in better shape cosmetically and in good shape physically, but the bearing and the hubs are shot. So when you spin the hubs, it feels like they're rolling in gravel. These are Shimano's special semi-aero spoke. I went to see if I could find these spokes online. Shimano doesn't sell them anymore, but you can still find them on the internet. They aren't expensive, but I couldn't find anyone in the US who actually had them in stock. Instead, I bought a cheap set of universal spokes. These are just a regular straight pull spoke. They're generic, they're not branded. These are 297 millimeters long. I pulled one of the spokes out of the wheel and measured it, and that's how I got the length. These are not aero, they don't match the profile of the other spokes, but I don't think that's going to be a problem. This is the nipple I removed from the wheel. There's nothing special about it. It's a 14 gauge nipple, it's 16 millimeters long. The only thing though is it's got this conical washer attached to it. And what this washer does is it spreads the load when this is tightened into the wheel. The nipples I have, they do not have that. So the area that contacts the hole in the rim is much smaller. I'm worried if I just use these the way they are that eventually they'll either pull through or crack the rim. So I went down to my local hardware store and for 68 cents, I bought a pack of number 4 brass washers. As they set, they will not fit over the spoke and they're flat, they're not contoured. But for 68 cents, a little bit of work, I think we can make them fit. This is an M6 nylock nut. I just had it around the shop. Those number 4 brass washers fit in there just perfectly. This is a 3/32 inch punch. This is the one I use for knocking divots in steel before I drill it. If we put the punch into the center of the washer and we drive it in, it will do 2 things. It will open up the end of that to the right diameter and it will bend a cone shape into the end of the washer. That brass washer fits over the spoke perfectly and now it's got the correct contour to work with the wheel. It's also the exact same width that the original Shimano washer is. So I think those will work. The cheap straight pull spokes fit into the hubs just fine. I used a second spoke to push the nipple through the rim and threaded it onto the spoke. I put a light tension on both spokes. I know you guys will be surprised to hear, but I don't own a wheel stand. Trust me, it's true. Instead, I just use an old frame and some zip ties. I used a tension gauge for the first go round. and then I fine-tuned the truing by listening to the zip ties. I went around the wheel adjusting spoke tension as necessary until the wheel was true. I'm calling this good enough. It's about 1/2 millimeter wobble still, but after it breaks in, I think I'm going to have to retrue it anyway, so we'll worry about it then. I mentioned earlier that the rear wheel has a big gouge in the rim. To fix this, I started by sanding to feather the paint. I then mixed some 2-part filler and filled in the gouge. I sanded it to shape with some 120 grit sandpaper and gave it 2 coats of Krylon textured black. This is my favorite paint for bike parts as it replicates a factory finish. So that's nearly it for the rear wheel. I have a plan to fix the front wheel, but it's a little sketchy. I disassembled the hub and removed the bearings. The right hand bearing is in good shape. The left hand bearing, not so much. The balls were rusty and both races severely pitted. This is why the bearings felt so bad. New bearings are way too expensive and just not in the budget. So instead, I reground the races. I used a sharpening stone in the Dremel, spun the race in the lathe, and ground the surface until the pitting was removed. I did the inner race exactly the same way. I only removed enough material to remove the pitting. I then polished the surface with some 600 grit sandpaper soaked in oil. The resulting surface isn't perfect, but it's much better. I replaced all the balls for both sides. There were 32 in total. I gave them a coat of heavy-duty grease and I reassembled the hub. Here's the front wheel after grinding the races and installing new balls. It spins quite nicely and it feels smooth. I realize this is not a precise solution. It really is kind of a last resort repair when bearings aren't available or you really don't have any other option. It's a crude method, but I've found that it does work. I finished the wheel set by installing new rim tape and fitting new valve stems. The one I used on the rear is green. It's just because that's what I had on hand. These wheels didn't have their spacers, so I designed and printed some new ones. I then installed a pair of American Classic Kimberlite tires. These are 700C by 40. They've got a really good tread pattern and do really well on fast gravel. I inflated the tires to 70 psi to seat the beads. Those last couple pops, they always scare me. This frame uses a PF30 bottom bracket. I really like using these thread together bottom brackets. I went with an off-brand as it's nearly $50 less than one from Wheels Manufacturing. This one uses replaceable sealed cartridge ceramic bearings. Installation is easy. Tap in the drive side cup, then screw in the non-drive side cup and tighten it together. The GRX crank I'm using fits into it perfectly. I tapped it into place, then torqued the arm to 13 Newton meters. The only derailleur that works with the road shifters in the mountain wide range cassette is the GRX 812. This will support gearing as low as 42 teeth. I'm using an M7000 SLX 11 to 42 tooth cassette. This is one of 3 wide range cassettes that work with the road shifters. The seat post is a generic carbon post. I took this one from the Kona after I swapped it for a longer post. These brakes are Shimano's R785s and they use Shimano's mineral oil. These levers came already assembled with the caliper, but I thought it was a good idea to flush the fluid. I actually found quite a bit of air in that rear caliper. Since I'm running a 1x setup, I only have to mess with installing one cable. I want to take a moment to talk about what this build cost. My goal when I started this project was to see how cheaply I could put together a mid-level gravel bike. And this Niner RLT9, it surely fits the bill. So I spent a total out of pocket of $484. So that's $484 worth of parts I actually had to go out and buy to put this together. I had a lot of the parts on hand already from previous projects, mostly parts I pulled off to upgrade. I looked around on eBay, I priced out used parts or parts that required work. I think it would cost you about $358 or an extra $358. So the total build project here for you, if you were doing it yourself, would be about $842. If you're willing to repair damaged bike parts or recondition the ugly ones, you really can put together a nice gravel bike in 2026 for under $850. I think this bike turned out great. I'm really excited to get out, ride it, put it through its paces. I've had a cold for the last week, so I haven't been able to get out on it just yet. I'm confident it's going to be an amazing bike. So that's it for today's video. I hope you guys got something out of it. I hope you enjoyed watching it. Until next time, I'll see you later.